Actually, I'm not sure at all. I'm going with arithmetic sequences, okay, not arithmetic. But then this is just plain old geometric, not
geometry.
Not geometry. Yeah. Good one though. Okay. If you are an arithmetic sequence, that means you really got me bad pen. What is going on?
You have a calibrator.
Oh, no. Arithmetic sequence means that you add or subtract
Oh, hold on.
by the same amount.
Could you please record this?
Yeah, I am.
Oh, you are recording?
To get the next term. Okay? So, pretty simple. Give me an example of an arithmetic sequence. Not all at the same time, just one of you, please. Don't shout out all examples. Well, give me the numbers. Okay, there you go. How about 1, 2, 3, 4, 5, 6, etc. Okay? Yeah, that's an arithmetic sequence. Okay? And this has a common difference of what? 1.
Comma or common?
Common difference of 1. Okay? And so the way that you write this formula recursively is you say to get the next term in the sequence, I take the one before it. What's the term before a sub n? A sub n minus 1. And what do I do each time?
Add 1.
Add 1. Okay? Oh, and you have to say where to start. And so in this case, A1 is 1. All right? How do you feel about that? Feel good about it? Feel good about my life right now? I wish this was my life every day.
That's awesome.
No, this is great. You see, guys?
Oh, smaller classroom.
Yeah, no courtroom, no tucker, no elevate. You're here, which is sort of a drawback, but we can work through it.
I'm sorry.
You said the same thing when like where's Bobby just recording.
Yeah, well, I felt that way then too. You should be honest, because you were here both times. That is what I'm asking you, Emily. Is this sequence arithmetic or not? Goes up by 4 every time, and so the common difference, which we're going to call D, equals 4. So this is an arithmetic sequence.
This is not arithmetic.
It's going up by 4 each time. What's the first term?
-6.
-6. What's the second term? -2. What's the third term?
2.
2. What's the fourth term?
6.
Okay, are you ready?
No.
It's a race. Next credit. What's the 100th term? Go. 90? No, definitely not 90. What is the 100th term? We just say numbers.
Can we do this in our head or should we use a calculator?
You should be able to kind of figure out a pattern a little bit. You started -6, I don't know where you're getting this negative.
Because you always go to the A sub 9.
Oh, I see what you're saying. Okay. Yeah, okay, I'm with you there. You see what Gabe said, we're really starting at negative 10 because a sub 0
Yeah,
like
yes.
would be.
I thought we were, I was.
It's 390. Okay, how'd you get it?
Yeah, we start negative 10 plus 4x.
390. You start at negative 10 plus what?
4x.
Okay, so he's going to go negative 10 because that's what A0 would be. And then plus 4x, where'd the 4 come from? That's the common difference, all right? And then since we want to find the 100th term, you plug in 100 for x. And really, I'm just going to change this a little bit just to be consistent with the book. We want to go for n, okay? So the any nth term would be start at negative 10 plus 4 times n. And so if n is 100, then the 100th term is 390. Does this look familiar to you at all?
Yes.
What do you, when have you seen that before? Yeah, more specifically? If I changed the variables into ones that you're more used to, like instead of saying a sub n, if I said y, and if instead of saying x, n, I said x like Gabe did, what is that? Equation 4a, y equals mx plus b. That's an equation for a straight line. It's going up by the same amount each time, right?
Yeah.
So the amount that it's going up by each time we talked about as being the slope when you were just little children, okay? And this number right here, which Gabe said is a sub 0, we talked about as being the y-intercept, which is what y equals when x equals 0. Okay? So there's a connection there to something that you've learned before.
Are we gonna have to make that connection and use it?
So many times I have to tell you.
I know.
We already made that connection for us.
Did we use it?
We will. Okay, arithmetic?
No.
No. Not arithmetic.
Geometry.
Geometric.
Oh,
Yeah.
not
Yeah,
geometry.
we'll get to that in a second, but this is a geometric sequence because you're multiplying by the same thing every time. What are we multiplying by each time? 1/2. Okay? So we're not going to mess with that because we're not ready to talk about those yet. How about this?
Yeah, I just wrote that down for no reason.
Not for no reason, because now you know what a geometric sequence is. How about the natural log of 3, the natural log of 6, the natural log of 12, and so forth. I learned that at this school when I had an exchange student from Belgium.
What did you learn?
Why it's LN and not NL. He said natural log was developed by a French mathematician. And in French, natural log is logarithme naturale. So he invented it, he got to make up the notation, we have to use it. You invent something, you can stick us with whatever you want. You could invent something called the unnatural log and say the deviation is MW. And everybody would just have to go with it. It's all over the world for all eternity. Why is the unnatural log MW? The unnatural log.
Someone who knows what you mean.
Exactly. Okay, geometric or not? I mean arithmetic or not? It doesn't look like it, right? Because these are doubling each time.
Yeah.
Okay. The one way that you can tell if a sequence is arithmetic or not is to subtract the successive ones. If you get the same answer every time it is. So, for example, what is -2 minus -6? I'll give you a hint. It's 4. What is 2 minus -2? 4. What is 6 minus 2? 4. What is 10 minus 6? 4. Okay, so one way to see whether this is arithmetic or not would be to subtract the successive terms. So what is the natural log of 6 minus the natural log of 3? Remember your rules of natural logs. What can you do when you're subtracting logs? Subtraction is the same as division. So this would be the same as the natural log of 6 divided by 3, which is the natural log of 2. What is the natural log of 12 minus the natural log of 6? Natural log of 2, using the same logic, because this would be the natural log of 12 divided by 6, which is the natural log of 2. And then the same thing is true for the natural log of 24. So what is D this time? Natural log of 2. Okay? All right, so this is a little bit harder to come up with the 100th term. So let's not do it.
Yeah.
Okay? Great minds think alike.
Are we going to?
Let's take a look at geometric. We already saw one of them. A geometric sequence is when you multiply it by the same thing each time. All right? So, somebody give me a geometric sequence. 2, 4, not 6 because that would be arithmetic. Yeah, 2, 4, 8, 16, 32, and so forth. What are you multiplying by each time in this one? 2. That's called the, not the common difference, that's called the common ratio is 2. And that is a lot of times R equals 2.
Could you restate the common ratio?
The common ratio is what you multiply by each time to get the next one. R is shorthand for the common ratio.
Why'd you write it twice?
Because I'm a bad teacher.
I'm sorry.
Well, I'm sorry, because you have to suffer through me.
You're still doing out there.
So you are the one that suffers. Okay, so let's take a look at some examples.
Oh, fractions.
Geometric, yes or no?
Yes.
Why? Because 2 times 1/3 is 2/3. 2/3 times 1/3 is 2/9. And 2/9 times 1/3 is no. This is times 1/3. And this is times 1/3. But then this is times who knows what. Okay, but it's definitely not 1/3. So it has to be all the way through the same thing. So this is not geometric. And it's not arithmetic either, it's yeah, which you probably don't.
Can I say geometric district?
Yeah,
Geometric?
Geometry.
Yes. It is.
Are you sure, Emily? What is the common ratio? 2. So we're multiplying by 2 each time, okay? So we can write this out recursively very easily. To get the next term in the sequence, what do I do to the term before it? Multiply by 2. So a sub n is going to equal 2 times a sub n minus 1. Okay? So let's play this game again. A1 is what? 3. A2 is 6, A3 is 12, and this time let's figure out what A20 is. Any bright ideas?
Would we just do the same thing that we did on the other one?
No, because now we're multiplying. Not 41.5. You can see if I double this, I get 24, and then double it again, I'm going to get 48, so I'm going to jump over that pretty quickly. It's going to be a big number. Okay? So here's the way you think about it.
So would it be two?
Here's the way you think about it. A1 is 3, right? To get A2, what did I do to the 3? Multiplied it by 2, okay, which gave me 6. To get A3, not what did I do to A2, but what did I do to the original one to get the third one? Multiplied it by 4, which is the same as multiplying by 2 twice. So I went 3 times 2 times 2, which got me 12. To get A sub 4, I went 3 times 2 times 2 times 2, which got me 24. Okay? So if I'm going to do A20, I'm going to go 3 times 2 times 2 times 2 times 2 times 2. What? 19 times. One less than the term that I'm trying to find. To get A2, I multiplied by 2 once. To get A3, I multiplied by 2 twice. So to get A20, I'm going to multiply by 2 19 times. Nicely done, Forrest. I take back everything I've ever said about you.
I wish.
Unfortunately, that means good and bad.
Wait, so you do 3 times 2?
Yeah. You take the first one and multiply it by 2 19 times. One less than the number of 20 times. Okay? I thought it was stupid. You're branching out, expanding your vocabulary.
I didn't get what did it equal?
It doesn't really matter. All right. What's the, we're on regular schedule today, aren't we?
Yes.
What time is this class out?
5 minutes.
Sweet.
What's the meeting for super?
No idea.
Next
I'll put it
period
up in a
at
second.
9:40.
Next period. What am I multiplying by each time? What am I multiplying by each time?
-2.
No.
Positive.
Right, 10 to the positive 2, because you add the exponents, right? Which is also known as 100. Okay? So, same deal, first term is 10 to the negative third, second term is 10 to the negative first. If I want to find the 20th term, what do I do?
What, are you adding on this one instead?
No, I'm multiplying still.
So it's just going to be a 19.
I'm going to start with the very first term, 10 to the negative third, right? Times, how many times do I have to multiply by the common ratio? 19 times, one less than the term that I'm looking for. So it's 10 to the negative third times 10 to the 19th, which is what? Oh, sorry, it's not 10 to the 19th, it's 100 to the 19th. My common ratio is 100. Let's not do that way because your calculator is going to freak out. 100 is 10, what? 10 to the 35th? Okay. So that's 10 to the 35th. Okay, what I'm going to do right now is I'm going to put an assignment on the board, but you guys are going to have most of the period tomorrow to work on it while the losers that are gone today try and figure out what the heck's going on. Okay? So this is probably due at the earliest, the beginning of class tomorrow. Okay? If you want to get a jump start on it because you got other stuff that you need to do, then go for it. Otherwise, I'm going to say maybe end of class tomorrow. Seems like it's pretty safe bet.
I'm not gonna be here tomorrow.
No, I don't know. You're more.
Oh, yeah.
every day is the third Friday in calculus class. Is that right, Coach?
That's right.
You guys done with everything?
Pretty much. Pretty much. If I wasn't gone so much,